Hello and welcome to my presentation. Myself, Aarav Atul Thigale. I am pursuing degree in ENTC branch, now ongoing fourth year in MMCOE college, which is located in Pune. So I will start the presentation now about the washing machine controller using PIC 16 FH77A under the guidance of Emertexe virtual internship on embedded systems. So special thanks to Jay Kumar Balasubramaniam sir, Director Emertexe, for these opportunities and encouraging students to involve in the process of this internship, and respected teachers who took lectures and gave guidance to us for the C module as well as MC module and the lot of sessions. So I will continue the presentation now. Pardon me for not including any index in the presentation. So I'm continuing. So now overview. The virtual internship hosted by Emertexe provided a comprehensive learning experience focused on embedded systems. Over the course of this project, we explored various aspects of microcontroller programming, real-time hardware simulation, and system-level integration. The core objective was to design us and simulate a fully functional washing machine controller using the PIC16 F877A, a microcontroller in a virtual environment. Tools such as MPLAB XIDE, XC8 compiler, and PiximLab were used extensively throughout the internship for programming and simulation tasks. So I will move forward. Now I will discuss what are the goals and objectives of the internship. The main goal of the internship was to enable participants to apply embedded system concepts in a practical project. We aim to gain a hands-on experience in configuring and controlling microcontroller peripherals, developing user interfaces using CLCDs and keypads, and writing efficient embedded C code. Specific objectives included understanding timer-based event handling, state machines design, interrupt-driven execution, debounce mechanisms, and simulating a user-friendly washing machine interface with real-time feedback and system response using PiximLab. So next. So in this slide, I will discuss what embedded systems are, and I included some information. So what are embedded systems? So embedded systems are specialized computing systems that perform dedicated functions within larger mechanical or electrical systems. They consist of both hardware like microcontrollers, sensors, actuators, etc., and softwares, firmware typically written in C or assembly. These systems are designed to be efficient, real-time, and reliable. In our project, the embedded system design centered around PIC16 F877A microcontroller, chosen for its wide set of peripherals. This include general purpose I/O pins, timers for delay, serial communication interfaces, and PWM channels. Embedded system enable automation, precise control, and flexibility, all of which were necessary in developing our smart washing machine control algorithm. I will move forward. So the major part which was included in this internship was embedded C, and at the first we have we have learned what C programming is, and basics were cleared. On the basis of the C programming, the embedded C has uh, taught. So now I will discuss about the embedded C language. So embedded C is a streamlined version of C language tailored for programming microcontrollers like PIC16F877A. It provides direct access to hardware registers and I/O ports, making it ideal for real-time control tasks. While it uses standard C syntax, it requires additional understanding of microcontroller architecture. Means in the code we had the CLCD coding. So in the CLCD coding, there was not a normal function to write. We needed a simplified version and the timer. So in the datasheet of the CLCD, that mentioned the sequence should be in a fixed, what I can say, pattern. So first of all, we had to add a minor delay around 4.1 millisecond. I don't exactly remember the values, but that was the sequence. So the CLCD program required normal syntax, but we had to add the additional knowledge about the architecture and sequence of the CLCD. HD HD 44780. So I will continue. Its ability to write compact and fast firmware makes it the preferred language for embedded applications like our washing machine controller. So embedded C, or I can say C, are comparatively the fastest languages, which means compiler languages. Unlike Python, embedded C compiles the code at once, and the output is obtained very fast as compared to the other languages. So embedded C is basically an extension of C, and all the syntaxes are same, but only thing changed is the hardware knowledge. So I will continue to present the next point is about PIC16F877A. It is a 8-bit MCU by Microchip 40-pin DIP package, dual inline package. Operating voltage is from 2 volt to 5.5 volts. Flash memory is 14 KB. Static RAM is 368 KB. Sorry, bytes. EEPROM is about 256 bytes. There are working 33 GPIO pins and 3 timers, which are timer 0, timer 1, timer 2. All are 8-bit. Built-in UI and ADC, which is 10-bit resolution. PWM, I2C SPI. This chip is suitable for intermediate to advanced embedded applications. So I will continue to next slide. I haven't added detailed knowledge about anything. It will take a lot of time to explain. So due to the time bounding, I'm not able to add it. So now I will continue with the project requirements. So these are the images I have took from the document which was provided in the internship, and my output is at the last of this session. So now I will continue. The washing machine project was designed to simulate a realistic user interaction and program execution. The system starts with a welcome screen prompting user to press a switch 5, which was the first requirement. And on the next screen, once the switch 5 is pressed, a loading screen simulates the powering on sequence, which means powering on of washing machine. And this blocks. So the next step was choosing from a list of washing machine programs including daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store. The program selection is made with using switch 4. Short pressing is used for navigation, which means the scrolling effect, and long press is used to confirm and enter into that mode. So the next point is following that water program screen, washing program screen, the water level must be selected from the following options: auto, low, medium, high, and maximum. After confirming selections, pressing switch 5 starts the timer countdown, which is the next step for start. But it has same like switch 4 is used for navigation and switch long pressing switch 4 used for selecting. So I will move forward. There should be a screen which shows the start and stop options. By pressing the start button, the program should start, and by pressing stop, screen get reverted back to selecting the washing programs. There should be a screen after pressing the switch 5 which shows the start, the display of the function, time, and the options of the start and pause should be done. By pressing the pause button, switch 6, the program should stop, and after pressing the switch 5, the program should resume. So next, after start of the program, there should be a function of door status check which occurs as we press switch 1 and status shows door is open, please close. At the last of the program, there should be a completion screen of program when the timer gets at 0 seconds. The message should be shown as the program is completed, remove the clocks with buzzer ringing for 2 seconds. So these are the all project requirements. I will move forward. This is the design representation. First of all, the switch 5 is used to power on the washing machine. Switch 6 is used for pause and stop, depending upon which condition the program is present. Switch 4 is typically used for navigation as well as long pressing it will continue the function. And there is a function of doer status which includes the switch pressing of switch 1 pressing, and then the message is shown that door is open, please close it with buzzer ringing continuously. And next, display on CLCD. The all program is displayed on the CLCD. Buzzer is used as a status checking and lots of stuff. Motor, which means the fan, is used to indicate the continuous status of the project. So the next is the tools used in this internship. First of all is MPLabX IDE tool, which is used to encode and decode the process. X8 compiler is associated with the MPLab XID, and the PiximLab is the hero in the story. All the things are done by PiximLab, and it was very simple experience to operate on the PiximLab. And uh, thanks for thanks Emertexe for suggesting this type of tools and giving us knowledge. I mean, this is beneficial for me, not for all. So the next slide is the peripherals used in this program. So there are majorly 5 peripherals, which includes the CLCD, which is their manufacturer are Hitachi. The model name is HD44780, which is a 16 into 4. I haven't got any image from the internet about 16 into 4, so please pardon me about it. So first of all, controlled via RSEN D4 to D7 connections. It requires total 6 connections on the PiximLab. It handles dynamic display of program name, timer, water level, and associated messages. It operates in a 4-bit or 8-bit NPU interface, main processing unit. Connected pins are port B, RE1 and RE2. So I will continue. Timer 2, which is inbuilt in this microcontroller, which is used as an interrupt. It is an 8-bit timer with selectable prescaler and postscaler. In the program, we don't need any post scaling. We only needed the prescaler, which was the default. It provides a consistent 1-second interval. Timer overflow flag TMR2IF used to update counters for minutes and seconds. This is part of program. I'm not explaining the program, and at the last of the session, please, I'm sorry for the low voice of the demo, but I will continue. Okay, the digital keypad is 4 into 4 matrix, which includes pull down register configuration to avoid floating input, map to port B pins, RB0 to RB5, debounced in software, which is done by adding a short delay. Short press used for navigation, long press used for confirmation, which is switch 4, which is on the board is RB3. So next, cooling fan used to indicate the status of function. The fan is rotated when the function is undergoing and until timer is not paused. Next is buzzer, active high digital output pin. used to indicate end of washing machine process or status changes, controlled via logic in the final state of cycle. Okay, this was all about the peripherals. Now I will move to the next part, the project demo. So I will continue to display the project demo. So this is my project. I'm going to explain the demo part. I would not include any technical knowledge, code into this. So this is my project. I'm going to start it. First of all, I will load the hex file. So I have loaded the hex file. Now I will continue to present. So project is started with pressing the switch 5 and the press 5 is switched. So I have mentioned the RB4 button here because when we had lectures, so in the lectures that they had shown what a switch 5, so we could easily get confused which one is switch 5 since it is named as RB4. So due to avoid the confusion, I have added RB4, so it could be easy for users. So I'm pressing the RB4 now. The loading screen, which is about 2 seconds, is shown powering on washing machine. Okay, now the next screen is here. So this is washing program. So these are the washing programs as shown. I will navigate with the switch 4, which is tactile switch RB3, daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse dry, dry only, wash only, aqua store, and daily. So our task here is to navigate this washing program with switch 4, which is RB3, and select the program by long pressing the switch 4. So I am long pressing the switch 4 now. Okay, I have pressed. In my code, I have mentioned it as long press is occur after 30 count. So now continue. This is a water level screen, which includes the water levels auto, low, medium, high, max. So there are 5 levels, and same as the previous screen, we have to navigate with the switch 4. And now I will select the mode, water level mode, by long pressing the switch 4. Now we have a screen where there are options to start the program and stop and get back to the washing program screen. So I will first show you stop screen. Stopping, it will get me at the washing program screen. So again I will change the mode and show you. I will show you two modes. One has very least counting, and one has very high counting, to show how this program has executed in minutes form as well as seconds form. I mean the timer. So I'm continuing heavy mode. Again the water level is auto. Now I will press the RB4, which is a obviously I have my own way to produce the code. So I have mentioned RB4 and RB5, which is very simple to identify on the board. So I will start, and now the program is shown and the time is shown for 5 seconds, and then we continue. So here is function, time, RB4 to start and RB5 to pause. So I will pause this. Now you can see the fan has paused. We don't need buzzer. So here the cooler is on is not showing, and timer is also paused. So I'm not explaining the code, but I will. No, 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 no. Okay. So now I will again start the code to run. So the work function is again started. The fan is also spinning. Function is wash. So we will wait until it gets done. Here showing wash program. Now it has changed to rinse. As you can see, it evaluates the time at the back end as we had adjusted, which meant as minus the current time, the wash time and spin time, we get the rinse time. Now there is chance of spin. So spin is the else condition of now. As you can hear, the buzzer has ringed as shown. I will show again another mode, which is whites. And I suppose this mode consists of very big timers. And I will show you. I am selecting high mode, and I'm promising that all the code is working. And I have almost tried this code and Pixim Lab about 100 times that my PC has lagged so much. So now I'm continuing. Again, I can stop. It will get to washing program. Now I will select whites with the switch 4 RB3. Again, again we continue. And now I will choose high mode, high water level. And now press the switch to RB4 start, RB5 stop. So I will start, and now I am starting. This requires 1 minute 7 seconds. So it will continue. And now it has begun. There are some errors. I think 7 seconds got vanished. So okay, it could be, I mean, accountable, but okay. This is last time glitch. Okay, okay. Now I will show you another function which we have added, which is the door is opened or closed. So I will press RP0, which is switch 1. You can see the fan has stopped. The buzzer is ringing. Okay, I will leave it. And the program is again started. Screen is changed. Timer has started. Modes are changing, which means it is acquired its previous positions. Here you can see fan is on. The function is getting completed. Spin mode. And now you can see done. Remove clocks for 2 seconds. So I will show you another modes, which is again change aqua store. I'm choosing auto. Okay, now it is selecting auto. Now I will start. Aqua store requires 47 seconds, so it will start. Okay, now RB4, RB5. So again I will show you by pressing RB5. It get paused. Now again to start I will press RB4, and also by pressing this I will warn you to close the door. The door is open, please close it. Continue. Now we can see the rinse mode. Now it will change to spin
No, no, no. Okay, okay, my mistake. That was Aqua Store. It only has rinse mode. So that's all by my side. This is my demo. If I continue to do this demo, it will get a lot of time. So thank you all. Thanks.
So, dear Emertexe, the conclusion of this internship was gained a solid knowledge about embedded design lifecycle, developed and tested a complete simulation project, integrated multiple peripherals using real-time logic, learned to debug and simulate using PixSimLab, which was my personal favorite, ready to implement similar hardware level projects in a real world scenarios. So that's all by my side. I hope your day goes well. Thank you for this opportunity and this internship. Thank you all. Thank you.